The U.S. Air Force bought 505 RF-4Cs, and the Marines 46 very similar RF-4Bs. These planes transformed the world's idea about reconnaissance aircraft with their Mach 2 performance and fit of sensors and other avionics. RF-4Cs also served in Vietnam. This is a recon picture of an SA-2 guideline missile site. This is the Hanoi thermal power plant before and after being bombed. Here, the destruction of the Don Phong Tan Bridge is confirmed. And the demise of the Long Dai Railroad Bridge. And this was taken just 150 feet above a very active 57mm anti-aircraft gun. The slogan of the RF-4C crews in Vietnam could very well have been, alone, unarmed, and unafraid. Even today, the RF-4Cs, first delivered in 1964, are still among the very best in the business. These aircraft can roar in overhead at extremely low levels, get their imagery by any of 4 methods, and transmit some of it during the mission by data link. RF-4s were especially helpful in Desert Storm, providing quick and useful battle damage assessment. This aircraft is also a variant of a twin-engine supersonic fighter, but a much smaller one. It's the Northrop RF-5E Tiger Eye, most of which is identical to the F-5E Tiger II fighter. The nose is slightly longer and much more pointed, the radar having been removed along with one of the 2 cannons. In the tip of the nose is a big forward oblique camera. This is imagery of a dam during a run at 200 feet at 600 knots. Just to the rear of the oblique camera is a large bay that can hold several kinds of pallets loaded with cameras, infrared line scan, forward-looking infrared, or 2 kinds of sideways-looking radar. This is the CL-289, called the USD-502 by the NATO armies that use it. The whole system was developed by Canadair in partnership with Dornier of Germany. SAT of France later joined to furnish an infrared sensor, as well as this radar, which was used to track the remotely piloted vehicle during development. Like all battlefield systems, the 502 has to be fully mobile. The basic vehicle is mounted on a rail launcher. It takes just minutes to attach the wings and control surfaces, then conduct the pre-flight check. On an operational mission, no radar is used, and the USD-502 flies a computer-controlled trajectory according to an accurately worked-out flight plan. Then the launcher is adjusted to the correct bearing and elevation. The small turbojet of 240 pounds thrust is started up and run up to speed. When all is ready, the firing button is pressed. The rocket blasts the vehicle off the ramp, and the burnout drops away to the rear. What is left is a small, agile, hard-to-detect, and very fast aircraft, cruising at about 500 miles per hour. On board are navigation and control subsystems, which would do credit to many manned aircraft. They enable the vehicle to follow a flight plan worked out in exact detail. A typical sensor pack has a 3-lens Zeiss camera and an infrared line scanner, both giving image resolution as good as that from a larger and more vulnerable manned aircraft. Real-time pictures are sent back by secure digital links so that the ground commander can study the enemy's activity without delay. The computer not only handles navigation, it can also manage the sensors. To reduce vulnerability, this tiny jet aircraft can even hug the ground on a quasi-terrain following mode. On return, it detects and homes on a beacon near the launch site. A signal deploys a 2-stage parachute. The CL-289 descends inverted and lands on 2 large airbags that cushion the impact. It's quickly recovered and driven away to be refurbished for another mission. In almost total contrast is the Harrier used by the RAF for both tactical reconnaissance and attack. Though primitive compared with the GR-5s and GR-7s now coming into service, the early model Harriers are flown by pilots of long experience. Here, a mission is being flown by Number 4 Squadron. The pilot navigates with his moving map and heads-up displays. Instead of weapons, his aircraft carries a belly pod containing 5 cameras. The pilot flies to the target manually, studying the familiar terrain and switching on the pod to record enemy activity. Harrier is one of the hardest manned aircraft in the sky to spot or shoot down. It's tiny, smokeless, odd-shaped, and very agile. These aircraft require no airfields, so they can survive day after day in actual warfare when other aircraft would have long since been destroyed. They can be deployed close to the front line, so reaction time is very fast, with a high probability of catching the enemy unprepared. Under the Harrier's belly are 2 30mm cannons. Almost before the Harrier has come to rest, ground crews unload the magazines from the cameras. Within minutes, the pilot is being debriefed.
It's my main target. You can just see my main target, but it looks as though the main armor has moved to this area here.
Your target is an infantry combat group.
And 2 attack pilots are sent to attack the armored concentration the first pilot discovered.
That is about 12.
This strike sortie involves 2 aircraft with a full rocket load going out at Mach 0.9. Nearing the enemy, they roll down almost to ground level to make their attack runs.
Go from the basically straight wing flight to engine-borne flight. That's where it gets tricky.
Lantern is short for low altitude navigation and targeting infrared for night. Lantern has a navigation pod and a targeting pod, both attached under the fuselage. Combined with the radar and the GEC heads-up display unit, Lantern enables the F-15E to navigate at a height of 200 feet by night or even in bad weather. The targeting pod gives a clear infrared picture of each target, assisting the lock-on of a Maverick missile, for example. The sensors in the navigation pod almost enable the pilot to dispense with any real forward vision. Instead, synthetic imagery is projected on cockpit displays and on the crucial heads-up display, enabling the pilot to fly with greater precision than the pilots of earlier fighters on a clear, sunny day. Lantern is also carried by the F-16, and F-16s are also flying with a different and in some ways more advanced system called Pathfinder. More than a dozen companies around the world are producing advanced electronic systems to enable low-flying aircraft to make precision attacks around the clock, no matter what the weather. In most cases, the only trick for the pilot is landing in bad weather. It is clear by now that reconnaissance sensors can operate in very different ways. Cameras are at one extreme of the spectrum, using light, while radars are at the other. In between come the infrared devices. They emit no telltale signals, as do radars. And because their imagery doesn't record colors, but surface temperatures, they provide far more information. An IRLS infrared line scan can sweep across a landscape by day or night. It defeats traditional camouflage. The resolution or picture quality is getting better all the time. Many companies are engaged in infrared research. Here, a British Aerospace 748 is recording infrared images on paper and on videotape. This infrared picture was taken as the 748 flew over a tank farm. An interpreter can see the exact fuel level in each tank and can work out many other facts, including the rate at which fuel is being pumped in or out. The aerial line scanner can see far more than the manager of the tank farm on the ground. This is a flyover picture of a large tanker. Intelligence officers can freeze the recorded image and enlarge any part of it. This is a fast run over an airfield at night, taken at a height of 600 feet. The amount of visible information that can be seen is amazing. This aircraft has cold fuel-filled wings, revealing that it's just landed from a high altitude. To its right, an aircraft has just departed. And a 707 has its left inboard engine running. This is an infrared image of a British suburb. Detailed inspection would show which rooms were heated, which chimneys warmed, places where cars had recently been parked, and cars with warm engines. Built secretly for the Central Intelligence Agency, the original U-2 was an unprecedented kind of jet sailplane designed to fly at extreme altitudes. Gradually, U-2s became more powerful, heavier, and were able to carry more varied kinds of reconnaissance sensors. U-2s were important players in the Cold War. In 1960, a U-2 was shot down over the Soviet Union, causing a political crisis. 2 years later, a routine overflight of Cuba revealed that the Soviets were supplying Fidel Castro with jet bombers and long-range missiles. This posed an obvious and unprecedented threat to the United States. The Cuban Missile Crisis had begun. President John F. Kennedy demanded that the Soviet weapons be withdrawn. The U.S. Navy was ordered to turn back any ships heading for Cuba with such cargo. World War III seemed likely to start at any moment. At last, on the 28th of October, the Soviet Union backed down and agreed to remove the threat. And on the 5th of December, the last IL-28 bombers were pictured leaving the island. A great crisis had been disclosed and then averted by aerial reconnaissance. The SR-71 resulted from the realization in the late 1950s that mere altitude gave no immunity from interception. Enormous speed was also needed, and Mach 3 was the target. But a Mach 3, or 2,000-mile-per-hour aircraft, could not be made of conventional materials. New titanium alloys were required to mold these very difficult metals into a working airframe. SR-71 pilots would be flying close to the edge of the Earth's atmosphere, at heights exceeding 100,000 feet. They had to dress in spacesuits for each mission. Every single thing about the Blackbird was new and had to be invented, produced, and tested. The hydraulic systems were designed to work at temperatures much hotter than any domestic oven. Even the fuel was special. It remained stable at extremely high temperatures and also served as the cooling fluid for the avionics systems. The Blackbird was also designed to be difficult to see on radar. In some ways, it was the first stealth design. But perhaps the most extraordinary thing about the plane is that it took only 22 months to design and build, and was all done in total secrecy. The first Blackbirds were called A-12s. The first flight was made on April 26, 1962, at a remote airstrip in the Nevada desert called Groom Lake. Development was rapid, with up to 18 aircraft in the flight line. Two were prototypes of the YF-12A long-range interceptor, with a Hughes radar in the nose flanked on each side by infrared receiver sensors. Underneath was a missile bay that could fire the powerful AIM-47 missile, a giant successor to the AIM-4 Falcon family. The interceptor design was dropped. The real need, the Air Force decided, was for the SR-71 Strategic Reconnaissance Platform. This was made slightly longer and considerably heavier than its predecessors, mainly because of the fuel needed to fly long-range missions. One SR-71A was converted into this SR-71C trainer, and others were built as dual-control SR-71Bs. All Blackbirds are powered by the Pratt & Whitney J58 turbo ramjet engine. At Mach 3, most of the thrust comes from the giant spike in the inlet. Nearly all the rest is contributed by the huge afterburner, which quickly becomes white hot. In April 1986, the SR-71 was essential in photographing the targets in Libya struck during the El Dorado Canyon operation. An SR-71 flew right over Tripoli in broad daylight, while the Libyan Air Force fighters and SAM forces were on full alert. It came back with the necessary pictures. These magnificent aircraft have been retired from Air Force service to air museums. Now, only NASA flies the Blackbird for high-speed, high-altitude research.